Hello everyone, we're going to do some more problems involving rates. If you're doing these from the textbook, there's the reference pages are there. I suggest everyone try them first, then pause and then play the clip and see how you go. So this first question, question 7, the number of hours of sunshine was recorded each day for 1 week in April. The results are listed below. Find the average number of hours of sunshine per weekday. So per weekday means that we are only interested in these hours because they're the weekday hours. So we need to go 6 plus 8 plus 3 plus 5 plus 7. Okay, and all together that gives us 10, 18, 23, that's 29 hours. Okay, 29 hours for the weekdays. Yeah. So I can write that in here. So per weekday means 29 hours. How many weekdays do we have? 5 days, Monday, Tuesday, Wednesday, Thursday, Friday. Now we want it per day. So the 5's got to be reduced to 1. We divide by 5. Do the same to this one, divide by 5. 29 divided by 5 gives us 5.8 hours of sunshine per day on average on a weekday. What about the weekend? Well, the weekend are these 2 days. So we only have 6 plus 7, which is 13 hours for the weekend. Okay, so we only need to consider 13 hours in 2 days. So 13 hours for 2 days, because that's the weekend. So we want it, again, to go back to 1 day. So 2 days to 1 day, I'd divide by 2. We need to divide by 2 there. So 13 hours becomes 6.5 hours per day. What about per week? That involves adding all the days up, everything up. So 6 plus 8 plus 3 plus 5 plus 7 plus 6 plus 7. Pause it if you want and work it out yourself, but I will just tell you right now, that's 42. Anyway, you should have tried it first anyway. So this is 42 hours per week. Now it's already per one of something, it's 1 week, so that's it. That's all we need to do. Whereas the per day, we've got the 42 hours, but how many days did we take it over? 7 days, and we want it down to per day. So we've got to divide by 7, do the same over here, divide by 7. 42 divided by 7 is 6 hours per day. Okay, the second part of the question, given the above rates, how many hours of sunshine would you expect in April? So the 30 days in April. Okay, so the hours of sunshine, you'd expect to have 6 hours for every day of April, so 6 times 30, which is 180 hours. Okay, question 8. We've got, just trying to put some more space in here. No, not working, I'll have to go with it. Harvey finished a 10K race in 37 minutes and 30 seconds. Jacques finished a 16K race in 53 minutes and 20 seconds. Calculate the running rate of each runner. Which one ran a faster pace? So usually with speed, we would go the time it took compared to the distance. So if we do Harvey, he took 37 minutes and 30 seconds to run 10 kilometres. So how quick can he run per kilometre? That's what I want to know. Now, before I do that, I've got this in minutes and seconds. So it actually makes it easier if I go 37 minutes and 30 seconds is actually the same as 37 and a half minutes in 10 kilometres. Just get rid of my strokes a bit long there. Okay, so that's 37 and a half minutes and 10 kilometres. So if I want to change that to per 1 kilometre, I need to divide by 10. And then obviously I need to do the same over here. 37.5 divided by 10 is 3.75 minutes to run 1 kilometre. Now we've got Jacques. So what's he doing? He's taking 53 minutes and 20 seconds to run 16 kilometres. Now, just like Harvey, I've got his time in minutes and seconds. I'd like to actually get it just in minutes. So 20 seconds is actually a third of a minute. So this is 53 1/3 of a minute. Now, to do 16 kilometres. Now, I want it to come back to per 1 kilometre. So I have to divide by 16. Do the same here. You can, on your calculator, go 53 1/3 divided by 16. And that gives us 3 1/3 minutes per kilometre. Now, that could also be written as 3.3 recurring minutes per kilometre. Okay, so 3.3 recurring, or 3 1/3, is actually shorter than 3.75. So Jacques is the one who ran the quickest. Okay, question 9. The Tungamah Football Club had 12,000 members. After 5 successful years and 2 premierships, they now have 18,000 members. What has been, what, so question A, what has been the average rate of membership growth in the past 5 years? And then we're having to have a question B. Yeah. If this membership growth rate continues, how many more years will it take to have a membership of 32,000? Okay, so what's been the, well, let's do question A, part A first. The average rate of membership growth for the past 5 years. So what's the growth? We went from 12,000 to 18,000. So you've got to go 18,000 minus 12,000, which gives you 6,000 people, 6,000 members. So the average growth rate is you have 6,000 members happening in 5 years. So what is that per year? We want to divide by 5. So we want to turn 5 into 1. Keep it the same, divide by 5. 6,000 divided by 5 gives me 1,200. So it's 1,200 members per year. Part B, this membership growth rate continues. How many more years will it take to have 32,000 members? So we need to grow to 32,000. So how many more new members do we need? We need to have 32,000 in the end, but we've already got 18,000. So we need 14,000 new members. Okay, so the time needed to take to do that will be the 14,000 divided by your 1,200 that you're getting every year. Oops, just 1,200, which is going to give us 11.6 recurring, which is actually closest to 12 years, because we need to go to the nearest whole number. That's it.